Okay, there's a couple different kind of degrees of difficulty regarding factoring. Okay, actually, let me start with even easier than that. Okay, so if I take this expression and I ask you to factor it, the first thing you should always look to do when you're factoring is look to remove any common factors. Okay, so in this binomial here, are there any common factors between those two terms? Any common multiples? Yeah. Look at the numbers. What common factor can we remove from the number portion of this? 5. And what common factor can we remove from the variable portion? An x. Always take out the x, or the power, with the lowest number. The lowest number is further to the left on a number line. And now this will come in handy later if you wind up factoring negative powers. Okay? Again, you always factor out the lowest number. It's whatever's lowest or furthest to the left on a number line. And when you remove a 5 and an x from this first individual term, basically factoring out and then finding what's going to remain in the groups, it's always going to have the exact same form as the original. So our original was a binomial separated by a minus. So when we factor out or remove any common factors, we still need to be left with a binomial. Okay? And so when we remove a common factor, you're basically going back into the original expression and you're dividing each individual term by whatever you factored out. So really, like again, here's a thought cloud for what you're doing. Okay? So you're taking 5x squared minus 25x, and you're dividing each term by that common factor that you're removing. So what's left in our first group here? The 5's cancel, 1x cancel, so we're left with a x. And then what's left in our second group here? Again, the x's cancel, 5 goes into 25, leaving a 5. So we get 5x times the quantity x minus 5. So that would be the factored form by removing those common factors. Okay, after you remove any common factors, what you're then going to look to do is you're going to look for any special factor forms. Okay, this book will introduce those a little bit later. Or actually, I'm going to go ahead and talk about them right now. So the special factor forms that you should be familiar with are the difference of squares. And if you have two perfect squares that are separated by a negative, does anybody recall what the special factor form is for that? You're going to take the sum of the terms that are being squared times the difference of those terms that are being squared. Okay, so again, if I move this down, if I gave you something like this, okay. So again, we're looking at binomial in this particular case, and this will always only apply if you're dealing with a binomial with a subtraction sign between the terms. Okay, but if you're looking for to factor this, you're going to first test and see, are there any common factors you can remove from both of these terms? No. So then you move to the next step, which is find any special factor forms. Is this the difference of two perfect squares? Okay, and so the way that you do that is just test it to see. Okay, is the quantity 4x squared a perfect square? Is it some number times itself? Yeah. What's the square root of 4? And the square root of x squared? And what's the square root of 81? Okay, so if you look at these bases that are being squared, you have 2x, quantity squared, minus 9 squared. And so when you separate this into our special factor form, we're going to take the sum of those terms, so 2x and a plus 9, times the difference of those same two terms. So 2x and 9, take the difference of them here. So that's going to be your factors for that problem. In addition to the special factor form of difference of squares, you also need to be able to identify what's called a perfect square trinomial. Okay, and a perfect square trinomial has the following form. Okay, the first and last terms are perfect squares. If you figure out what's being squared to get those terms, and you double the product of those bases, and that's the middle term, then what it allows you to do is quickly find the factors as simply the sum of the two terms that are being squared. And so if I take this same set here, all right, so if I take this expression here, and I look to see, does this fit the pattern of a perfect square trinomial? The way that you look at that, just very quickly, are the first and last terms both perfect squares? Yeah, so it's the same thing. Identify what's being squared. And then if you multiply these two bases together and double that, do you get the middle term? Is 9 times 2x doubled equal to 36x? Yeah, if that's the case, that's the pattern you're looking for. And so you can automatically rewrite this as a binomial square. And the two terms of that binomial are the bases that you squared here. So 2x and 9. And then the sign of them is going to be whatever the middle term sign is. So this middle term has a plus, so that's going to be a plus here. Let's see how that fits in a separate example. All right, so let's say here's the problem that we're looking to factor. And so if we look at this, we look to see, are the first and last terms both perfect squares? Yep. So we can test it. What base can you square to get 9x squared? 3x. What base can you square to get a 16? 4. So now we're going to multiply these two bases together and double that product. So 3x times 4 is 12x. Double that, you get 24x. Is that our middle term? Yeah. So that allows us to rewrite this as a binomial square. The two terms are 3x and 4. And then our sign is whatever this middle term sign is. So in this particular case, we're now going to be dealing with a negative. And then we also are looking at the pattern where if the first and last terms are perfect squares and the middle term is twice the product of the bases that are being squared. So here's the patterns that we're looking at right now. Does this fit either of those patterns? No. Okay. But can you factor something out of it? What's the first step in all factoring? Remove common factors. Are there any common factors here? Okay, so if we're factoring, remove an 4, we're left with an x squared plus what's left when we remove or divide out a 4 from 16? 4. Okay, now, when you look at this, is it still two perfect squares here? Yeah, it's x squared and 4, which is 2 squared. But does it fit the pattern of the difference of those? And this right here, this form, a squared plus b squared, is called irreducible over the reals, meaning in the real number system, you cannot factor this. Now, in the complex or imaginary number system, which we're going to get into later in this chapter, you can find factors of it. But in the real number system, the sum of squares is irreducible. It has no factored form other than any common factors that can be removed from it. All right. Again, hopefully you can solve these and see them quickly. It will save time if you're familiar with them. Lauren? Okay, so since we're looking at a binomial, so here's a binomial, and then here is a trinomial. So let that kind of guide you first. So we're checking this binomial. Is this the difference of two perfect squares? And so when we look at this, is there a number that we can multiply by itself to give 16? 4. And then t squared is just the t. And then what about the 9? Yep. So once you identify those, it fits the pattern of the difference of squares. So you just type in your terms, 4t and 3, and then you're just going to take the sum of them times the difference of them. And that'll be your factors.